All right, guys, welcome back to CollegeBoard Practice Test 1, Section 4, Calculator Allowed Math section. Let's get started. All right, number 1. John runs at different speed as part of his training program. The graph shows his target heart rate at different times during his workout. We can see this on this graph. On which interval is the target heart rate strictly increasing, then strictly decreasing? Right? So we want the trend where it goes up super fast and then it suddenly drops super fast once again. So we're looking for that interval. So let's look through the choices. Now, let me give you guys a little hint here, okay? It's not going to be always, but for the sake of SAT, I highly suggest you guys check in the answer choice D first, especially when you have to run through all the choices like this, because most of the times SAT people want you to waste your time on this timed test and make you go over from choice A, choice B, choice C, only to realize your answer choice is actually on the bottom, choice D. Now you just have wasted 2 minutes. So it won't be always like I just said, but for the sake of the SAT, always try to start with D. But here, I'm going to start with C because I see this in order. And if I just check whatever's in the middle, I should be able to see if I'm going to go left or right from that point. So if I want to check B or D later on, right? So let's just look at C. Between 50 and 65 minutes. So let's look at that. 50 is right here. It looks like it's at the peak here. And 65 is like, it's like right there. It's also a peak there, right? So 50 and 65, right? It goes down first from 50, and then it goes up. So it strictly decreases, and then it strictly increases, right? So is that what I'm looking for? I'm looking for strictly increasing, then strictly decreasing. Okay, this is exactly the opposite. From here, strictly decreasing, and then strictly increasing. So that's not what I'm looking for, right? So let's just look at that. I see the one maybe over here, so is that, that looks like 70 to like 95. So I can check D. Between 70 and 90 minutes. So let's look at that. 70 is like right here. So it goes up, stays for a little bit, and then comes down. So increasing, then decreasing. I kind of like that. So I'll keep this. I'll keep that. And what about this? Between 40 and 60 minutes. So 40 is right here. Oh, it goes all the way up. And then until 60 is over here. Oh, it goes all the way down. Okay, so it increases and decreases. So I like that too. Between 0 and 30, 0 is over here, 30 is over here. It goes up a little bit and just stays there until 30. So I don't really like that. So now we found the trend, right? So it's either B or D, but we want, what do we want? We want strictly increasing, then strictly decreasing. So we don't want anything else happening in the middle of it, right? We want it to strictly go up and then strictly go down right afterwards, right? So which one of these two actually does that? Between 40 and 60, it goes up and then it goes down. That's 40 and 60. Between 70 and 90, it goes up, stays for a little bit, and then comes down. So what matches the strictly increasing and strictly decreasing more? Choice B. Does that make sense? All right, number 2. If y is equal to kx, where k is a constant, and y is equal to 24 when x is equal to 6, what is the value of y when x is equal to 5? All right, so let's get started. Like I just said in the previous lecture, always start with something you kind of have an idea of what to do. So we know y is equal to 24 when x is equal to 6, and we have the equation given. So why don't we just plug it in and start from there, right? So y is equal to kx. We know y is 24 when x is 6. So k times 6 is equal to 24. So we can just divide by 6 on both sides to get k is equal to 4, right? So we found that. And what are we asked to find? What is the value of y when x is equal to 5? So what's y when x is equal to 5? Well, we just found out that k is 4, and it said k is constant, so that 4 doesn't change. So k is 4, x is 5, y is 20. My answer choice, C. Very, very simple question. Number 3, in the figure above, lines L and M are parallel. So let's mark that. Line L and line M, they are parallel. And S and T are parallel. So S and T, these guys are also parallel. Right? If the measure of angle 1, that guy, is 35, let's mark that too. So 35 degrees here. What is the measure of angle 2? All right. So this is a very simple question dealing with geometry concept where we talked about all these types of different corresponding angles, right? Corresponding angles, alternate interior angles, alternate exterior angles, vertical angles, and so on, right? So let's use some of those knowledge and apply here, right? So first of all, that angle, what is it same as? That one as vertical angles. That one's also same as this one, corresponding angles, right? So let's just do that. Let's just, because I'm going to get to over here. Like, I got to find this missing angle here. So I'm going to use that and first go here, and then hopefully I'll jump onto there, right? So this angle 35 is same as here since they are corresponding angles. So I know that's also 35 degrees. And I know that angle and that angle are also the same because they are also corresponding angles, right? And I can only say that because these lines are parallel and these lines are parallel, right? So I can look at it as these two lines and that transversal, or I can look at it as these two lines, parallel lines, and that transversal, right? But whichever way, we can apply all these sorts of alternate interior, alternate exterior, corresponding, and so on, all those angles. Then it just simply becomes a straight line, angle 2 and 35 degrees. So I can do 180 minus 35 degrees in order to get angle 2, which will lead me to 145 degrees. So my answer choice, D. Well, you could have done that, or let's say you were stuck. For whatever reason, you couldn't remember those corresponding angles, alternate interior, alternate exterior, all the angles, right? Take a look at the problem. If that's 35 degrees, right? And, you know, that looks about 35. Well, maybe not too much in my picture, but that definitely looks less than 90, right? For sure. I mean, look at that. The angle looks less than 90. Look at angle 2. That definitely looks more than 90, right? For sure, because 90 is like that, right? And that's definitely more than 90. Look at the answer choices. A, 35. That's not more than 90. B, 55. That's not more than 90. C, look at 70. That's not more than 90. The only choice that is actually more than 90 degrees is choice D, 145 degrees. So if you had absolutely no idea, you could have just used a simple common sense and be like, okay, if that's 90, well, that looks bigger than 90. D is the only choice that actually makes sense. So if I have to guess, that's probably going to be my best shot. Number 4, if 16 plus 4x is 10 more than 14, what is the value of 8x, right? Okay, so let's just write that out in better mathematical language. So 16 plus 4x is 10 more than 14, right? We can all do that, right? And now I'm about to show you guys a little trick here. So a lot of times when you face an equation like that, what does everybody do? Go ahead and solve for the x, right? I'm going to do that, and then I'm going to show you if I had to actually do that, right? So let's solve for that first. So 16 plus 4x is equal to 24. Subtract 16 on both sides. 4x is equal to 8. Pay attention here. 4x is equal to 8. What does everybody just naturally do? Divide by 4 on both sides. And you get x is equal to 2. And the question is asking for what? The value of 8x. I found that x is 2. So 8x is 8 times 2, which gives me 16, my answer choice, C. Now check it out here. At this step, over here, I was already done. I really shouldn't have gone any further than that. Because take a look. It says 4x is equal to 8. What am I asked to find? 8x. Isn't that double the 4x? If 4x is equal to 8, what is 8x? Probably 16. I never had to solve for x and then plug it back in here. Over here, I was already done. I should have been done, right? Because 4x is 8, that means 8x, which is what the question is asking for, is 16. My answer choice C. So if you like that method, go ahead and try to think about the next time you do the similar problem. Or if you never liked it, you like to solve for the x and then plug it back in because that's the original way of going about your problem, then stick to your own way. Number 5, which of the following graph best shows a strong negative association between D and T? Right. So let me label these axes, D and T. Right. So we're looking for a strong negative correlation, right? Negative association, right? What does that mean? Negative association. Well, negative association, aka they are negative of each other, aka they are opposite. So when they are talking about negative association, or another term for association would be correlation, right? Negative correlation or negative association, they are talking about when one variable increases, the other variable decreases, right? So positive association would be one goes up, the other goes up. Negative association would be one variable goes up, the other variable goes down. Does that make sense? So in this problem, we're looking for some sort of a graph when we graph it out on these 4 choices. That's going to be when one goes up, the other goes down, right? So between the 2 variables D and T, when the D goes up, T should go down. When T goes up, D should go down, and vice versa, right? So let's look through the answer choices. First of all, let me kind of go ahead and just guesstimate the trend of all these points on each of the 4 graphs that you're looking at. So let's look at A. It seems like if I kind of roughly draw the trend of all those points, it looks something like that, right? Like in the very middle. For B, I don't know. It looks something like that. Kind of like a straight line almost. C, it looks something like that if I kind of guesstimate the trend. And D looks something like this. Now, what do we say in the beginning? We want a strong negative association, aka one goes up, the other goes down, right? So let's look at A. As D goes up from left to right, seems like T is coming down. So T is going down when D is going up, right? I like that, so keep. B. It's like the same. When D is going up, right, as it goes from left to right, seems like T is just kind of like staying the same. So T is like the same, right? It's like whatever, right? No change, almost no change. C. It looks like when D is going up, right, as left to right, T is also going up, right? Which is what we don't like, right? And choice D, as D goes from left to right, aka when D goes up, the T also seems to be coming down, right? So, just by looking at these 4 trends, I can go ahead and get rid of this guy because that's not what we're looking for. One goes up, the other goes down. I can get rid of that guy because that one's going up, like both of them with each other, right? So we're between A and D. Now let's go back to the problem and read it again. Which of the following graph best shows a strong negative association? So it's got to be pretty strong and obvious, right, that it is negatively associated. A. You see how all these points are kind of like scattered? So, you know, I could have drawn a line that kind of guesstimates like that or like this. Who knows? Like it's kind of hard to tell. But if you look at D, right, you see how the points are very close to each other and creating that trend right there, right? So clearly that is more obvious, aka stronger negative association between the 2 variables, and therefore my answer choice is D. Number 6. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, over here, how many 1 milligram doses are there in one 2 decagram container? Let me try to do this with minimal amount of math possible, right? So let me try that. 1 decagram is 10 grams. So let me just kind of be like, oh, okay, so 1 decagram is like 10 grams, right? And then 1 gram is 1,000 milligrams. So out of this, if I like break it into 10 pieces, I don't know how I do that. Let's just do this. How about that? That's 10, right? So if I take that little one of that, and take out, that's 1,000 milligrams. All right, so like I'm barely touching any math here, right? I'm just drawing stupid diagrams. It's not even diagrams, it's just like stupid pictures, right? So out of the 10 different boxes, which represents, so one box would be like 1 gram. It says 1 gram is 1,000 milligrams. I hope we're familiar with all these grams, milligrams, and decagrams by now, but I'm just doing it just for the sake of assuming that we don't really know this, right, prior to this question. So what do we ask? How many 1 milligram doses, aka how many of these guys are there in 1 2 decagram container, right? So 2 decagram container, that's D and D, right? And we just said 1D is this, right? And the other D is also this, right? This is kind of dumb, but whatever, right? I'll show you the math part of it, but I'm just doing this for the sake of whoever really doesn't like the whole math part, right? So, and we just said this one box is 1,000 milligram, right? So take a look. You've got a whole bunch of milligrams here then, right? Because we're asked how many 1 milligram doses are there in these 2 Ds, right? But take a look. That's 1,000. That's another 1,000, 1,000, 1,000, 1,000. It's a whole lot of thousands, right? AKA, that total over here would be 10,000 because I've got 10 of these 1,000 milligrams. And that's also, milligrams. And that's also 10,000 milligrams. So the total of 20,000 milligrams, AKA my answer choice D, right? Well, or I could just be like, it's just a whole bunch of 1,000 milligrams all over. It can't be A. It can't be B. It can't be C even because 2,000, come on, man. That little thing is 1,000, right? That little box is 1,000. You've got like 20 of them. No way it's 2,000. So the only answer choice that actually makes any sense is choice D. Now, this method is for people who really don't like the math part, right? Like they just don't want to do the whole unit conversion thing. If you don't want to do that, you can just draw stupid pictures like this, just like how I did it, and actually do the problem. I'll share the math part, which I personally believe is a much easier way to go about. But once again, this picture was just for people who really don't like the math, part of it, right? So let's take a look. We are asked to find how many 1 milligrams and 2 decagrams. So just start with 2 decagrams, right? And I'm going to do the unit conversions, right? So I'm going to multiply. And I'm going to try to cancel the decagram. And what do I have the conversions for? I have decagrams to grams. I have that. So I'm going to use that, decagrams to grams. The only reason I'm putting decagrams on the bottom is so that I can cancel the decagram here on top with this one, right? And what do I know for sure? 1 decagram is 10 grams, right? And then check it out. When I cancel the decagrams, I'm going to be left with grams as my unit. But I don't like that because I have to put it in milligrams, right? So I'm going to use grams to milligrams unit conversion. Once again, the reason I'm putting the grams on the bottom is because I want to cancel the grams on the top here, right? You guys all see that? So what do I know the unit conversions for this? I know 1 gram is equal to 1,000 milligrams according to the box here. Then I cancel out the grams, and you see how the decagrams got canceled, the grams got canceled. The only unit I have left is milligrams over here, right? So when I multiply all the units out, that's 2 times 10 times 1,000, which gives you 20,000 milligrams, math part of it, right? So once again, there are 2 different approaches to this problem. You can do it something like this when you just completely forget the unit conversion math part, or if you're more familiar with just doing math part of it, then this is the way that you can do this problem. Number 7, if rooftop solar panel, NG. Number 7. The number of rooftops with solar panel installation in 5 cities is shown in the graph above over here. If the total number of installations is 27,500, what is an appropriate label of the vertical axis of the graph? Okay, so these are the 5 cities, A, B, C, D, E. And the total is supposed to be 27,500, right? And we want to find out what should be the label on the vertical axis. If I look at the choices, it all says number of installations. So I would assume that here is number of installations. I just need to know in what unit though, right? Either tens, hundreds, thousands, or tens of thousands. So let's take a look. A's got 9, so I'll just mark 9. B's got 5. C's got 6. D's got 4, and E's got 3.5, right? So let's add them all up. That's 10. That's 14. So that's 24, 27.5. Oh, look at the number. When I add them all up, the total installations come out to be 27.5. The actual number they said is 27,500, which means from here I gotta go 1, 2, 3 and create the 2 missing zeros here, right? In order to match the 27,500, right? So moving 3 units to the right, that is same thing as multiplying by 1,000, right? 3 zeros, right? We moved 3 zeros to the right, so we should have multiplied by 3 zeros, right? Which means the number of installations should have been in thousands. My answer choice is choice C. Number 8. For what value of n is absolute value of n minus 1 plus 1 is equal to 0? Once again, let's put that into more mathematical language, right? So absolute value of n minus 1 plus 1 is equal to 0. Let's solve for that. Subtract 1 on both sides. Absolute value of n minus 1 is equal to -1. Now, stop. Don't even go any further. Stop. Just stop everything you do. Absolute value is what? What does absolute value do? Absolute value changes everything into positive, right? So let's say absolute value of -14. Well, that's equal to 14. Why? Because, once again, what does absolute value do? Absolute value takes anything, whether positive or negative, and changes it into positive. If it was positive to begin with, it's going to carry the positive as it is. If it was negative like this, it's going to change it to positive without changing the magnitude. Look, what did we just say? Absolute value changes everything into positive. Look at this. What does it say? Absolute value of n minus 1. Let me just say this. Absolute value of something is equal to -1. Does that make any sense? Think about it. We just said absolute value changes everything into positive. How can you take absolute value of n minus 1 or freaking absolute value of anything and end up with a -1? It just doesn't make any sense. So is there any value of n that can satisfy this equation? No, there is no such value of n to match this because, once again, absolute value of anything cannot be negative here. Does that make sense? Number 9. The speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave, in feet per second, and T, the air temperature, in degrees Fahrenheit. So, which of the following expresses the air temperature in terms of the speed of a sound wave? So, pretty much, in the problem, we have A is equal to something, but in the question, we want to figure out T is equal to something, right? So, we have A is equal to 1052 plus 1.08 T, but we want, so T is currently over here, we want T's equal to something, right? So T is equal to what, right? So pretty much we're moving things around, right? So with this, with the original equation, I'm going to move some things around to try to leave the T alone. The very first step would be subtracting the 1052 on both sides, right? Then I get A minus 1052 is equal to 1.08 T. And then, in order to leave the T alone, I would divide by 1.08 on both sides to leave the T alone. So now, that'll cancel, and I'll have T is equal to A minus 1052 all over 1.08, which is my answer choice A. Now, let me give you guys a little tip here. Once again, this is a timed test. I keep on mentioning this, right? This is not a test where you're given all the time in the world. You're given only a certain amount of time and you got to finish your test within that time. Check it out. I subtracted 1052 on both sides and I got to this part, right? I got to over here. Whatever my answer choice is, it better include A minus 1052, right? I can go ahead and look at the choices. A minus 1052, it's got it. B, A plus, nope. 1052 minus 8, nope. Nope. The only choice that you could have actually picked is A when you were on this step. You actually didn't have to solve the rest of the extra step in order to solve this problem. Number 10, following the same question, at which of the following air temperature will the speed of a sound wave be closest to 1,000 feet per second? Okay, so what's 1,000 feet per second? The speed of a sound wave, which is A here, right? The variable A. So that A is 1,000, right? So A is equal to 1052 plus 1.08 T, of which the question gives us that A is 1,000. So plug it in here as it is. And then we're just solving for T, right? So subtract 1052 on both sides to try to leave the T alone, right? That means we get negative 52, right? Negative 52 is equal to 1.08 T. You divide by 1.08 on both sides. The T is probably roughly about negative 48-ish. So my answer choice, B. Now, I'm more familiar with, doing mental math, but at this point, negative 52 divided by 1.08, I'm sorry. I said 1.08 and wrote 1.05. Divided by 1.08. Negative 52 divided by 1.08, just punch it in your calculator, right? Don't try to do it in your head, just punch it in your calculator. But roughly about negative 48, answer choice B.